Another, right? There used to be an examination some years before, almost a decade before, a ATM examination. This is the question. A is the product of four consecutive positive integers. Let the four consecutive integers is a plus 1, a plus 2, a plus 3, a plus 4. Now we are doing the product. Let P is the product. A plus 1 into a plus 2 into a plus 3 into a plus 4. Which of the following statements is not true? Suppose if I do first with the last, this is nothing but a square plus 5a plus 4. Second and third, a square plus 5a plus 6. If I call it as k, this will become k plus 2. K plus 2. This is nothing but k into k plus 2. K into k plus 2. This is nothing but k square plus 2k. K square plus 2k. First option. P is perfectly divisible by 24. If I take the lowest product of four integers, 1 into 2 into 3 into 4, 24, perfectly divisible. Next is 2 into 3 into 4 into 5. Perfectly. 2 3s are 6, 6 4s are 24, 24 5s are 120. These are perfectly true. P plus 1, it is a P plus 1, it is a perfect square. P plus 1, it is a perfect square. If I add 1 to it, it is definitely P plus 1, it will become K plus 1 whole square. Definitely, it is a perfect square. This is also true. Next one, P minus 2, P is not a perfect square. Definitely P is k square plus 2k. Without adding 1, it cannot be a perfect square. This is also a true. Not a perfect square is definitely a right statement. P minus 2 is a perfect square. That is an incorrect statement. This is an extremely important observation, sir. This is an extremely important observation. K into k plus 2 is not a perfect square. P plus 1, it is a perfect square. P plus 1, it is a perfect square. P plus 1, it is a perfect square. I hope the idea it is clear. Two questions based upon this one. Suppose if the question is square root of 1 plus 20 into 21 into 22 into 23. Now if you see here, this is nothing but of the form just now we discussed. A plus 1, A we will do, otherwise. Instead of just understanding the theory, we will create problems in the class so that you will understand it. To 20, it is k. 1 plus k into k plus 1 into k plus 2 into k plus 3. So, these is nothing but 1 plus k into k plus 3, k square plus 3k. These is nothing but k square plus 3k plus 2, k square plus 3k. It is nothing but a. So, these is nothing but 1 plus a into a plus 2. So, these is nothing but a plus 1. It is k square plus 3k plus 1. So, answer is 20 square plus 3 into 20 plus 1. 400 plus 61. Answer for this question is 461. One application of whatever the concept that we discussed. One application of whatever the concept that we discussed. Idea it is clear. Here the difference is 1. Here the difference is 1. So here it is 1. I will come back to that point. I will come back to that point. I hope it is clear how to solve. Product of four consecutive positive integers. If I add 1 to it, it will become a perfect square. It will become a, this third point is what we used it. Third point is what we used it. Now let us see. Suppose see here. Suppose A. Next let me take a difference to A plus 2, A plus 4, A plus 6. Let me see. A plus 6. What we should add to make it a perfect square? Let us see. It is nothing but first and last. A square plus 6a. This is nothing but a square plus 6a plus 8. This is nothing but p into p plus 8. So this is nothing but p square plus 8p. This is nothing but p square plus 2 into p into 4 plus 4 square minus 4 square. Are you all with me? So these are nothing but k equivalent to p plus 4 whole square minus 4 square. So k plus 4 square, k plus 4 square. I hope it is clear, right? K plus 4 square is p plus 4 whole square. There is a reason what I am trying to say. How many terms are there here? 4 terms are there. What is the difference? It is 2. So if a plus 2, a plus 4, a plus 6, 4 terms are there and the difference is 4. These are nothing but a perfect square. These are nothing but a perfect square. Are you all with me? A plus 2, a plus 4, a plus 6. If these terms are having a same common difference and the number of terms are 4, this value will be a perfect square. Where I suppose if it is 1 into 4 into 7 into 10. 1 into 4 into 7 into 10. What is the difference here? Difference is 3. Difference is 3. How many terms are there? 4. 3 power 4. Add it. Just check it out whether you are getting a perfect square. 280 plus 81, which is 361. 361 is 19 square, which is a perfect square. Are you all with me? Are you all with me? One more. 1 into 5 into 9. 1 into 5 into 9. Right? 1 into 5 into 9 into 13. Difference is 4. 4 power 4. 5 9s are 45. 45 into 13. Please check it out whether you are getting a perfect square or not. Definitely you will get a perfect square. 4 terms. I hope the idea it is clear to you. I hope the idea it is clear. Next one. Again it is an original exam question. In a certain year, it does not matter whether it is a leap year or a non-leap year. Whether it is a leap year or a non-leap year, January will have year. Whether it is a leap year or a non-leap year. Whether it is a leap year or a non-leap year, January will have 31 days. January will have 31 days. This is something which is definite. The month of January had exactly 4 Wednesdays and 4 Sundays. January 1st of that year, if it is January 1st, after 7 days it will be again the same day. After 7 days, after 7 days, after 7 days. Let me go with the answer option. Suppose if I take the first option as Saturday, this is Saturday. This will also be Saturday. This will also be Saturday. This will be Saturday and this will be Saturday. If January 1st, if it is Saturday, 2nd will be Sunday. Are you all with me? 3rd will be Monday. 4th will be Tuesday. 5th will be Wednesday. 5th will be Wednesday. 5th will be Wednesday. So 2nd will be Sunday and 5th will be Wednesday. Question is, the month of January had exactly 4 Wednesdays and 4 Sundays. If 2nd is Sunday, 9th will be Sunday, 16th will be Sunday, 23rd will be Sunday, 30th will be Sunday. How many Sundays we got? 1, 2, 3, 4, 5. 5 Sundays we got. But what is the question? It is 4 Sundays. That means first option it is incorrect. First option it is incorrect. I hope you are all there with me. Just to go by the substitution, you will get the answer very, very easily. It's an easy question. Just what you need to do is just to do the plug-in. So January 1st, it cannot be Saturday. Suppose if I do Monday, Monday, this will also be Monday. This will also be Monday. This will be Monday. And this will be Monday. If it is Monday, January 1st is Monday. 2nd is Tuesday. 3rd is Wednesday. If 3rd is Wednesday, 10th also will be Wednesday. 17th also Wednesday. 24th also Wednesday. 31st. Again, how many I got? 5 Wednesdays I got. But the question is Monday. I hope right now you have understood the logic, right? How am I doing it? Similarly, if I take it as Thursday, January 1st as a Thursday. If January 1st is Thursday, 2nd is Friday, 3rd is Saturday, 4th is Sunday. If 4th is Sunday, 11th is Sunday, 18th is Sunday, 25th is Sunday. 4 Sundays which I got. If 4th is Sunday, 5th will be Monday, 6th will be Tuesday, 7th will be Wednesday. If 7th is Wednesday, 7th Wednesday, 14th Wednesday, 21st Wednesday, 28th Wednesday, 7, 14, 21, 28. So it is again 4 Wednesdays and 4 Sundays. So my assumption is right. Just to go by the answer option, you will get it very, very easily. I hope it is clear. Just a counting based problem, this question. Next one, yes. Let S be the set of all prime numbers greater than or equivalent to 2. Okay, we are adding, we are multiplying only. So 2, next it is 3, next it is 5, next it is 7. All prime numbers less than 100. 2 into 3 into 5 into 7 till 97. How many consecutive zeros will come? To get consecutive zeros at the end, we need 2 and 5. Only 1 power of 2 is there, 1 power of 5 is there. 2 5s are 10. That means 1 0 will be there at the end. Answer is 1 0 will be there at the end. 1 trailing 0, 1 0 at the end. Simply take 2 and 5 because number of zeros at the end is nothing but the highest power of 10. To get the power of 10, we need power of 2 and 5. Answer is 1 0 at the end. Next one, there is a triplet A. Next one is A plus 2. Next one is A plus 4. A plus 2, A plus 4. They are all prime numbers. What is the concept that we will use here? Any prime number greater than 3. Every prime number greater than 3. It is of the form 6k plus or minus 1. But reverse may or may not be true. Reverse may or may not be true. Reverse may or may not be true. All the numbers which are of the form 6k plus or minus 1 may or may not be a prime numbers. 25 is such an example. 6 into 4 plus 1, but it is not a prime number. Any prime number greater than 3, it is of the form 6k plus or minus 1. If the number is a prime number, it should definitely be of the form 6k plus or minus 1. Lowest prime number is 2. 2 plus 2, 4. 2, 4, 6. 6 is not a prime number. 2 not possible. Next it is 3. If it is 3, 3 plus 2, 5. 3 plus 4, 7. 3, 5, 7. It is a, all the 3 are prime values. So one triplet it is there. Any prime number greater than 3. It is 6k plus 1 or 6k minus 1. If it is 6k plus 1, these 6k plus 3. It is 6k plus 5. 6k plus 3. 6k it is divisible by 3. These also divisible by 3. So if any number divisible by 3, how can it be a prime number? So it is not possible. If it is 6k minus 1, these 6k plus 1 and it is 6k plus 3. These are divisible by 3, these are divisible by 3. These 6k minus 1 not possible, 6k plus 1 not possible. So only triplet which will satisfy all the 3 are prime numbers is 3, 5 and 7. How many possible solutions will be there for A? Answer is only one solution will be there and that value is A equivalent to 3. 2, 4 and 6 not possible. 3, 5 and 7 possible. 6k plus 1, 6k plus 3. 6k divisible by 3 plus 3 divisible by 3. Not possible. These also not possible. Next one. Let x and y be positive integers such that x is a prime number, y is a composite number. When I say x is a prime number, first it is 2, only even number. 2 is the only even prime number. Rest all are odd numbers. 3, 5, 7. All are odd numbers. Similarly, and y is a composite. Composite also, it can be an even number or it can be an odd number. All the cases we have to do. Y is a composite number. It can be an even number or it can be an odd number. Now, let us see. First case. Y minus x cannot be an even integer. Y minus x cannot be an even integer. A composite number can be even. Prime number also it can be even. Even minus even, it can be an even integer. It can be an even integer. This statement is not true. X and Y cannot be an even integer. Even into even, it can be even. This statement is incorrect. X plus Y by X cannot be an even integer. If X is 2, Y is, for example, if I take X is 3, prime number, right? Other than even also we can take X is 3, Y is 9. Y is 9. X plus Y by X. This is nothing but 3 plus 9 by 3. 12 by 3. 12 by 3 is 4. 4 is an even number. These also is violated. So what is the answer? None of the above statements are true. All the statements are possible cases. A prime number 2 can be only even, remaining all are composite. Composite, it is even and odd. Y minus X. Y minus X. Even minus even, it can be even. X into Y. Even into even, it can be even. X plus Y by X. I took X value 3, Y value 9. 3 plus 9 by 3, 12 by 3, 4. 4 is an even number. So that is also ruled out. Option is D. I hope the idea it is clear. Next one. Again it is a cat question. Reminder. When 1421 into 1423 into 1425 divided by 12. So the answer is nothing but first divide 1421 by 12, then add 2, then add 2. 12 ones are 12, 22. 12 ones are 12, 101. 12 eights are 96, 5. These 5. These 2 more than this number, 7. These 2 more than this number, it is 9, divided by 12. 5 into 7 into 9 divided by 12. You don't need to do 1423 divided by 12. 12 ones are 12, 22. 12 ones are 12, 101. 12 eights are 96. Now, 35 divided by 12. 12 threes are 36. Negative remainder minus 1. Minus 1 into 9. Minus 9. Negative remainder minus 9. Positive remainder will be plus 3. Positive remainder will be plus 3. I hope the idea it is crystal clear, right? Very, very easy question it is. Let us not spend too much time. This is a very good question based on base system. Very, very good question based on base system. But I will not solve this question. First, I will solve a simple question to understand a concept. In which base system? In which base system? 1 4 whole square. In which base system? 1 4 whole square equivalent to 207 valid. In which base system? 1 4 whole square equivalent to 207 valid. Listen carefully to this question. This question will give a very good understanding of how to find out the base without actually using any of the quadratic expressions. How most of the students solve this question is, in which base system? First of all, 14 whole square is 196. 14 whole square is 196, but the right hand side is 207. 207, right? That means this question is incorrect in decimal system. Let me find out in which other base system it is right. 1 4 into 1 4 equivalent to 207. In some other base system it is right. In some other base system it is right. In some other base system it is right. Because even 14 is an even number. Even number on square. Even into even it is even. Right hand side it is an odd number. So definitely in decimal system it is incorrect. In which other system? Let us do it. These how most of them do it. X power 0, X power 1. So these X plus 4 whole square equivalent to X power 0, X power 1, X power 2. This is 2x square plus 7. So these are nothing but x square plus 8x plus 16 equivalent to 2x square plus 7. So these are nothing but x square minus 8x minus 9 equivalent to 0. X is nothing but 9. This is how most of the students solve this question. Right? I don't want my students to solve it by using these quadratic, anybody can solve it, but can you develop a smarter way of solving it without using mathematics into it? Let me go back and discuss a 4th class NCERT concept, then I will tell you another way. In which base system 1/4 whole square equivalent to 207? Valid. Answer is 9. Now alternative method, listen carefully. Method 2. But before we discuss method 2, now see here. 27 plus 38. It is nothing but 65. 27 plus 38. How you got 5? Now listen. Both the numbers are in decimal system 10. First what we did, 7 plus 8 is 15. 15 divided by the base. 15 divided by 10. 10 ones are 10. What is the remainder? What is the remainder? Remainder is nothing but 5. What is 5 here? 5 is nothing but the unit digit of a number. So same logic I will do it here. 1/4 into 1/4 equivalent to 207. 1/4 into 1/4 equivalent to 207. 4 4s are 16. 16 divided by some base system. I got the remainder. That remainder is nothing but the unit digit of a number. Yes or no? That P is nothing but 9. 16 only when divided by 9. I will get the remainder 7. 9 ones are 9. What is the remainder? 7. Are you all with me? 4 4s are 16. 16 divided by which base system? I will get 7 as the remainder, which is nothing but the unit digit of a number. So that is nothing but 9. 9 ones are 9. So remainder is nothing but 7. Just by sheer observation, you will get these logic. One more question. I hope the idea it is clear, right? 7 plus 8 is 15. 15 divided by which base system? 10. 10 ones are 10. What is the remainder? 5. 5 is nothing but the unit digit of a number. Unit digit of a number. Next, 2 more questions which we will solve, so that then while solving this CAT question, it will be much easier for us. 53 into 15 equivalent to 732. In which base system? In which base system is this statement right? Now see here. What is 3 5s are 15. 15 divided by which base system? I will get 2 as the remainder, which is nothing but the unit digit. P is nothing but 113. 15, 13 ones are 13, remainder it is 2. P is nothing but 13. I hope the idea it is clear, right? Third one. 3 2 plus 2 4 equivalent to 100. 3 2 plus 2 4 equivalent to 100. In which base system is this equation right? In which base system is this equation right? What is 2 plus 4? 6. 6 divided by some base. I got the remainder that happened to be the unit digit. That happened to be the unit digit. Now you might get it out. Anil sir, here multiple answers I will get. 6 by 1, 6. 6 by 2, remainder 0. 6 by 3, remainder 0. 6 by 6, remainder 0. But in a base system 1, digit 2 will not be there. In a base system 2, digit 3 will not be there. In a base system 3, digit 4 will not be there. So I will get only one answer. That answer is P equivalent to 6. I hope you got the idea, right? 2 plus 4 is 6. 6 divided by which number? I will get the remainder 0. Any factor of 6 will give a remainder 0. 6 by 1 0, 6 by 2 0, 6 by 3 0, 6 by 6 0. In a base system 1, digit 2 will not be there. In a base system 2, digit 3 will not be there. In a base system 3, digit 4 will not be there. So answer is 6. 3 questions. I hope you got a good idea of how to solve it. Now this question, complicated question, let us do it little slowly without using too much of mathematics. Let us do. In a certain number, the difference of 5333 minus 555 is equivalent to 4445. So instead of working with the subtraction, let us move it to the right hand side. 5333 equivalent to 555 plus 4445. What is the unit digit? 5 plus 5, 10. 10 divided by which base? I will get the remainder which happens to be the unit digit. Unit digit is 3. So P is nothing but 7. So the first thing, this question is right in base system 7. This question is right in base system 7. Next one, then the sum of the numbers 3,555 plus 333 is how much? Let us see. 5 plus 3, it is 8. 8 in base system 7. 8 in base system 7. 1, 1. Answer unit digit should be 1. These eliminated. 5 plus 3, 8. 8 plus 1, 9. 9 in base system. It is 1, 2. So here 2 will come. So these also incorrect. Without using mathematics, you can solve the question if you have understood that example very well. Minus 555, if it goes to the right hand side, it is 555 plus 445. 5 plus 5 is 10. 10 divided by which number? I will get the remainder 3. That P value is nothing but 7. Or you can also go by the answer option approach. If it is 4221, these in base system 7. These in base system 7. In a base system 7, what is the digital sum? Divided by 6. If I divide by 6, these is nothing but 10, 15, 18. 18 is perfectly divided by 6. So these is nothing but digital sum 6. These 6 out. 6 plus 3, 9. 9 divided by 6. So 9 divided by 6, remainder 3. 4 plus 2, 6 out. What is 2 plus 1? 3. 3 equivalent to 3. If you are good in digital sum problem, you can solve it by using answer option. Again, I am explaining you. 5 plus 5 is 10. 10 divided by which number? I will get 3 as the remainder when I divide by base. 10 divided by 7. 7 ones are 7. Remainder it is 3. So P is nothing but 7. This question is right in base system 7. 5 plus 3 is 8. 8 in base system 7 is 1, 1. 1 top is 1. 5 plus 1, 6. 6 plus 3, 9. 9 in base system 7, it is 1, 2. So the last two digits has to be 2, 1. I hope the idea it is clear, right? Or you can go by the digital sum concept. If you go by the equations method, the problem will be extremely cumbersome. I hope the idea it is clear.